Hello guys, my name is Bob. Welcome to the Excel Math channel. In the last episode, we talked about how a random variable works. So basically, if we were to refer back to the last example, we talked about x defining as a random variable of outcomes of coin toss. So if x is 1, that means the coin toss outcome is a head, and if x is 0, the coin toss outcome is a tail. All right, so for this kind of random variables whereby it takes on only a finite countable values, either a 1 or a 0, so we name this x as a discrete random variable. All right, so a discrete random variable simply means it takes on a finite countable values, all right, or of values. All right, so another case whereby if I were to define y as a random variable of outcomes of a dice roll. So if I roll a dice, I have 6 outcomes. So that is either 1, 2, 3, 4, 5, 6. So as this 6 outcome itself is finite, hence y itself is also a discrete random variable. Okay, so here's a very short example of what is a discrete random variable. So the next thing I'm going to talk about is that other than a discrete random variable, I can have this thing called a continuous random variable. So what exactly is a continuous random variable? So this continuous random variable takes in infinite, okay, number of values. For example, if I have a random variable y, and I define this random variable y to be the height of the students in a school. And what are the possible values of y? Well, it could actually range between from, let's say, 1 meter all the way to 3 meters, all right? Just for example. So because within this range itself, it has infinite number of values, hence we define y as a continuous random variable. So for random variable itself, there are 2 types. Number 1 is a discrete random variable whereby it takes on only a finite countable of values. Number 2, either that or it is a continuous random variable whereby it takes on an infinite number of values. We also talk about that for each outcome of the random variable, we assign a probability, and the sum of the probability of all outcomes will be equals to 1. So in the case of this example, x itself, we have the probability of a coin toss outcome is head at 0.5. Right, let's put it this probability. And the probability of a coin toss outcome as a tail is also 0.5, and the sum is actually equals to 1. Or in other words, we actually define it as probability x is equals to 0 plus probability x equals to 1. and that is equals to 1. All right, where x equals to 0 is the outcome of a coin toss being a tail, while x equals to 1 is the outcome of a coin toss being a head. All right, and now the thing is that what if, let's say, we could have a formula? All right, we could have a formula in which if we were to sub in these values of x, I can find my probability. Then it will be great, right? Because it will be easier for me to do it, okay, with a formula. Okay, so let me just change this probability into somewhat of a different probability. All right, so let's say, for example, if the coin toss, the probability of getting a hit is P, all right, where P is somewhere between 0 and 1, which defines or which matches with the properties of probability, because properties of probability says that probability has to be between 0 and 1. And then we define 1 minus P as the probability of getting a tail from a coin toss. And I define a formula such that I'll be able to get this probability. So I have P times X bracket 1 minus P times 1 minus X. All right? So I have this formula in which if you were to sub in X is equals to 1, all right? If you sub in X is equals to 1, you just basically get P is equals to, the probability is equals to P. And when you sum in X is equals to 0, your probability is equals to 1 minus P. So yeah, we have this particular formula. And there is a name for this formula. So the name of this formula is actually called the probability mass function. So basically it's just a formula to sum up, okay, or to help you find the probability of an outcome when you sub in the numerical value of the outcome itself. In this case, if I were to sub in 1, I can get the probability P. If I sub in 0 into this formula, I can get the probability 1 minus P. And this formula itself is called the probability mass function. And probability mass function is catered to, or it actually identifies what kind of discrete random variable is it. All right, so probability mass function is only for discrete random variables. So that's all for this video. 3 things that we have learned. First thing, discrete random variable, it takes on only a finite countable of values. We talk about continuous random variable where it takes on an infinite number of values. And we talk about this particular formula itself, in which if we were to sub in the numerical values of the outcome, you can get the probability of the outcome. This formula itself is called the probability mass function, which tells you the different kinds of discrete random variables. In the next chapter or the next episode, I'm going to talk about continuous random variable and what we call the probability density function, which has the same concept as a probability mass function. Thank you guys for watching, and I will see you in the next video.